All right, here we go with solving systems of equations, but this time with elimination. Now, this can be found in your packet that you received at the beginning of the year on the back of notes number 1. So I've broken this up into 2 lessons rather than doing it as one, and they are 2 completely different ways of solving systems of equations, okay? So by the end of this lesson, you should be able to solve a system of equation using elimination, and that word elimination tells you a lot about the process that we're going to be using today. We're going to be looking to eliminate, to cancel something out. So again, we're faced with the same problem. We're faced with 2 equations and 2 variables. If this was an equation with 1 variable, we'd be able to solve this easily, but without with 2 variables, it makes it much more difficult. Now we can use one equation against another. And so we have a few things here to help us get through this. Make sure you line up the pieces. Make sure that the x's are above the x's, the y's are above the y's, and the numbers without variables are also lined up. Look for or create additive inverses. Another word for this are opposites, okay? Coefficients that are opposite are going to be huge today. Remember, opposite of 3 is negative 3. Opposite of negative 7 is positive 7. And then we add those equations together. Now you could also subtract, but it is easier to think about just adding them together, trying to create opposite signs, and then solve, and then don't forget to substitute back to find the second variable. If you found x, go back and find y. If you found y, go back and find x. So let's look at these 2 equations a little bit more closely. 2x plus y equals 4. Negative 2x minus 4 equals y. Now, these equations already have additive inverses, all right? And if you look closely, it's right here. It's the 2x and the negative 2x. They're opposites. So something's cool is going to happen when you add their equations together. When you add them, you're going to get a 0, all right? So this is technically going to cancel out. Now, always put in the 1s. This is the common mistake that students make when doing this. Y is really 1y, and so when you add it with negative 4y, that makes negative 3y, okay? So we're just adding the 2 equations together to create one equation with 1 variable, which is something that we can solve, which we'll continue to do in a second. 4 plus a negative 10, even though we are told to add, signs are different, so I know I have to subtract and get negative 6, okay? Now let's undo the multiplication. Let's solve this equation with 1 variable using our normal equation rules of property equality. Whatever I do to one side, I do to the other. So that's going to give us y equals a negative divided by a negative, a positive 2. And there you have it. Simply adding those 2 equations together created one equation with 1 variable, and therefore something that we could solve. Now that's not the end. Don't forget we can go back and solve for y, solve for x using y, and we have to. Now it's our choice to pick which one we want to use, and I would say that the top one looks a little bit easier to do that with. So let's go ahead and use the top equation. And again, I chose that just because I felt like it was the easiest one to use, where I'm going to substitute in 2 for y, because 2 is y and y is 2. And there we have it. Once we do that, instead of there being 2 variables, there's just this 1 variable, and then it's a classic equation that we've solved, 1,000 times. So let's subtract 2 on both sides. 2x is equal to 2. We're going to divide by 2 on both sides and end up with x equaling 1. And there you have it. You have just solved a system of equations using elimination. Remember that this is the point where these 2 lines meet on the graph, always coming to you as an ordered pair in terms of x comma y. All right, let's take a look at the next one. The next one is a little bit more difficult because the variables are lined up. We have 5x over 4x, 9y over negative 3y, 10 over 8, but there's no additive inverses. 5 and 4 are not opposites, nor are 9 and negative 3. So what can we do? We have to create the opposites. Now let's try to see if there's a simple multiplication step that we can take to create opposites. So you kind of got to be good with your math facts here, but I see 9y here and negative 3y, and I know that I can easily multiply 3 by something to make it 9, right? So let's do that. Now if I'm going to do that, I have to do it to the entire equation. And it's totally fine in the math world to multiply everything by 3. If you make it 3 times bigger, just make sure everything gets 3 times bigger. So this new equation is going to become 12x because it's 3 times 4. Then I'm going to multiply 3 times negative 3 and 3 times 8. So this will be negative 9y equaling 24. Now the top equation does not change. No reason to change any of these because it has what we want. It has the opposite of negative 9y, which is positive 9y. You'll get more familiar with this. You'll start to see it a little bit faster the more you work with these. And again, this is a review, so hopefully we already have some of this knowledge from last year. So now what I want to do is go ahead and just add the equations because I have opposites that are going to make 0. All right, additive inverses cancel each other out. So 5x plus 12x is 17x, and then 10 plus 24 is 34. So there you go. What we've done, and this is so important to realize, we've gone from an equation with 2 variables down to an equation with 1 variable. And once we get to 1 variable, now we can use the normal steps we have to solve this. So let's undo multiplication, divide both sides by 17. Use your calculator if you need it, but 17 goes into 34 2 times. So there you go, x equals 2. This time we found x first. Now it's our job to go back and find y. Now it does not matter which equation you use the original one, okay? Don't use the one that we made 3 times bigger to find the y value. I'm going to stick with the positives. I know that one's a little bit bigger, but I'm going to go with the 5x plus 9y equals 10. Negatives just freak me out, okay? So I'm just going to take my 2, my x value, and substitute it in. So using the same skill we did last class to find the other value. So once we substitute it in, order of operation rules come into effect as always. Multiply first, we end up with 10. Then we're going to want to subtract 10. Now, we're going to get 0, but don't be freaked out. 0 is a number 2, okay? So we got to treat it like all the other numbers. So 9 times y means we undo multiplication with division. And so how many times does 9 go into 0? Just when you thought this was hard, it was actually easy, it goes in 0 times. So the y value was 0. Don't forget that this is a point on the graph where these 2 lines meet, and that point would be at 2, 0, which is known as their solution. The only point on the entire coordinate plane that makes both of these equations true. Okay? Next up is, what if I want to use my calculator? Well, you totally could, but with the elimination ones, you got to be careful because there's usually more steps. Now, this is the first example. It's the same one we just did a few minutes ago where we had opposites. And whenever we have this, I highly recommend you do this the algebraic way. You go through, you add them, and you just simply, find the x, find the y value, and then find the x like we did. Now, if we run into one that's a little bit more complicated and you want to try to use the calculator, I'm going to show you how right now, okay? So we've got 2x plus y equals 4. Well, in order to put this in the calculator, I'm going to need to solve it for y. So let's undo this by subtracting 2x. Let's remove the 2x from the left side, additive inverse there, and have it reappear on the other side as a negative 2x plus 4. And that was easy, not too bad. We have y by itself. Now, we got to do the same thing with this other equation. So let's solve for y. Currently, it's negative 2x minus 4 equals negative 10. So let's go ahead and do the same thing we did on the other side for the other equation. Add 2x on both sides. Negative 4y equals 2x minus 10. Now that I've got the x over there, the negative 4 has got to go. So let's undo that with division. Remember that all pieces get divided to get the y by itself. There it is, 1y or just y. Try to reduce when you can. 2x over negative 4 would be negative 1/2. 2 out of 4 is half of something. And then the negative 10 divided by negative 4 would be a positive. So let's make it positive. So there's just one sign. And the best we could do is take it to a decimal or reduce the fraction. So 4 goes into there 2.5 times. Or you could write that as 5 over 2. Okay? So that's going to happen when we're trying to use the calculator. Sometimes we're not going to get whole numbers. So just be prepared for that. Now, let's go ahead and put these in the calculator. So grab your calculators And if you don't have a calculator, you could always do this on Desmos. Go ahead and press the y equals to enter the equation. First one up was negative, and make sure you use the negative button, not the subtraction sign, 2x, and then we're adding 4. Okay, scroll down a little bit, and now we have to enter the negative 1. Remember, x has to go in the numerator, it has to go in the top. Simply divide to make the fraction and put it over 2. And now the other one was the 5 over 2. So you can enter it as a fraction, 5 divided by 2, no problem there. You could also use just your decimal value, which we said was 2.5. So either way you do it, it's going to work out. Now you can see them entered in, and we have a graph here of what they are pictured, and that's what we want to shoot for. We want to go to that graph. We could also find it in the table. Let's do it with the graph first. So second trace will bring us to what we need. And remember, we need to find where they intersect, where they meet. So I'm going to press number 5, and it will draw the graph, and it will pull up our little Spider-Man. And so we got to bring the spider to the point where they meet, where that car crash happens. So that's going to be to the right, and that'll slide it down. Remember, if you press the up and down arrow, it'll just jump back and forth from one line to the next. Make sure you always see this in the bottom of the screen. First curve, question mark. Yep, guess where that is. Second curve, now we're on the other line. Guess that one. And for the third time, just tell me the numbers I need to know, and they intersect at 1, 2, which is what we found when we did it algebraically. Now, how could you do this in the table without going through that whole second intersect process? Well, second graph brings up the table, and when you see this, notice that the only time where the y values are the same is right here, when it was 1, 2, and then a 2. So that same y value is an indication that that is the solution. Any other time, the y values are different. All right, so there's another way you can come up with your answer. And I just want to kind of get back to the fact that yes, we found it the same way, same answer, doing it the algebraic way. Okay, I hope this has been a good review of solving equations using the elimination method, and we'll see you on the flip side.